our first topic, right, in the data science sector, the very first topic, which is NumPy. Okay, so first of all, it is very important to understand about the NumPy and going up to the SciPy, to the Seaborn, Matplotlib, and all. Okay, 1 minute. Is it audible now? Still not. Uh, my microphone is fine, I think. Okay, so very important thing. So first we will start up the data science. It is NumPy. We will be starting up with the NumPy. But before going to the NumPy, it is important. Like you should know what is the directory of the file you are working, and where your files are being stored up. Like whenever you want to download or you want to share up your things, from where you should copy or where do you should take the files. So let's say the very first thing is to import the OS operating system, and from there you can see your current working directory, that is os.get cvd, that is current working directory. And my current working directory, that this notebook is inside the users, then the name, and uh, then your folder, right? So it is inside this folder. Okay, inside this folder. So we are about to start about this numpy. Okay, so if I define this numpy, right, this is one of the most important package used for numerical Python, right? That is for doing up all the numerics, or you can say all the basic, not only the basic, but some standards mathematical calculations. Okay. Now, you can import it as something, right? As of anything. Like I have written NumPy. So the very first thing is like to check what is the version of the NumPy we are using. So NumPy version would be underscore underscore, one second, np dot underscore underscore, not np because we have did not taken it like that. So numpy underscore underscore, and then the version underscore underscore, and you will be getting up the numpy version, right? So numpy version I'm using is 1.18.1. Okay, fine. Now, so this is the numpy version I'm having on, right? Now this numpy basically most of the time, and even every time you can say on, deals with the arrays. Okay, so when creating any array, so that is difference between the arrays and the numpy arrays and the list and the Python and all, right? So there is a lot of difference between the things. We'll see what are the difference, how this difference works and all. Okay, so let's just take that why we prefer numpy array as compared to the list. Why we compare these things? Why we prefer these two as more for the list, right? Let's say that we have a L1 as a list one, okay, and let's say range of yes, someone is asking thing. How many of you are still facing voice issues? Okay, how many of you are getting like all of you are getting the voice issues? What about Abhijit and Almas? You are still getting the voice issues, right? If it is like jaggering or something like that. Any voice problems? Okay. What about Abhijit? No. Why it is going for the there? Hmm. Okay. Mute, unmute, mute, unmute. I think it would work there. Okay. Then let's say there is a range of some numbers, right? Okay, let's just say that this is a list. And you're saying for I in range of, let's say, 1000, right? So for I in range of 1000, what you have to do is you have to write L1 dot append I. That's it, the very basic thing. Okay, so you did it. Now you see if both this says, right, and now you see this dot get size of this L1. So what is the size of this L1? So 9032 bytes. So for 1000 numbers, it is taking 9032 bytes of spaces. Okay, that's nice. Now, if I say that this is an A1, right, that is an numpy array 1. So here I'm going to write it as numpy dot, or let's say this is again a list here. Alright, and what I will do for I in range, or not in range, for in numpy dot a range of 1 minute. So for I in numpy dot a range of 1000, right? I'll say you what is arrange, and I'll write that arrange means arrays range. That's it, right? And let it to be A1 dot append in this I, right? And we'll convert this A1 as np dot, sorry, numpy dot array of A1. Okay, and after completing up the loop, we'll be just converting this as an array. Now, what is the type of this A1? So this is a numpy ND array, that is n dimension array. Now we'll be deeply discussing about what is numpy, what is n dimensions, what are these n dimensions. Am I audible now for everyone? School, fine. So, okay, let me just close this files. This is 23. And this is going up there. Okay, he might be facing some issues. So type of A1 is numpy.nd array. Okay. Now if we see up for the A1, right? What is A1 if we just see it for there? So A1 would be some 1000 numbers, and you can see up there that this is an array, okay, of some 1000 numbers. So I will just remove this for now, right? And now I'll be saying to see the size of this A1. What you can find is that A1 is storing up the same 1000 numbers. A1 is having the same 1000 numbers, but the size it's having is 8096 bytes. As compared to the size of the list is 9032. You can get it there, right? That is important. So the numpy arrays are much far better as compared to the list, we can say, right, in the size. Also, within the execution of the time, if we say that is again, it's still better, right? All right. Now we can see that there is an ND array, that is n dimensions array. So what are dimensions here? So dimensions here refer to the number of rows or the number of columns you're having in your array, right? So let's just say that this is I'll be importing it as NP because I'm familiar with NP, right? I don't have a habit of writing numpy every time. So let's say we are making an array, and that is np.array. So what are the dimensions? Let's starting from the zero dimensions things. So if I write np.array and only one parenthesis, right? So inside the parenthesis, I'm not giving any brackets, not even the first, not even the these square brackets, right? So what I'm doing is I'm just writing up the numbers. So this is an array, right? This is an array. But what is the dimension of this array? So for checking the dimension, you will be using dot ndim, right? See of the things, right? Ndim, that is number of dimensions. This will be giving you the number of dimensions you are having in your ARR. So if you run this, you'll be getting a zero dimensions, right? And the basic idea for this dimensions is like, let's say this is ARR, and I'm making it as something different array. So this is np dot ARR AY. So this is np dot array, and now I have made some brackets, right? I have given one bracket, that is a square bracket, and I can write 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, what is the dimension of this array? So this is one dimension array or one dimension figure, right? So how we say this to be a one dimension? The only basic fact is like you are having one square bracket after the parenthesis. You are having one bracket opening out there, so that is one dimension. Okay. Now, similarly, if we say for this ARR and we say np dot array, and here I write 1, 2, 3, 4, 5, and let's just say that, okay, 1 minute. If I make some two brackets here and I say 1, 2, 3, 4, 5, and here as 6, 7, 8, 9, and 10. Okay, so we made some 1, 2, 3, 4, 5, and 6, 7, 8, 9, and 10, right? Now you can see that the two brackets are starting from here and we are ending with two brackets, right? So what will be the number of dimensions? If you can just see, the ndim would be 2 dimensions. Now what are these arrays? If I just print this, so this is right 1, 2, 3, 4, 5, and 6, 7, 8, 9 like a matrix. So 2 rows and 5 columns over there. So if we see the shape of this, so we can find it there that this array is having 2 rows and 5 columns. Or you can say this is having two particular rows, and inside that two rows there are having the total row is having 5 particular elements, right? Respective rows are having respective 5 elements. Okay, fine. Moving up, so that is how you can find the number of dimensions of any particular array. Now, what are the type of this array? We are seeing it as ND array, right? And numpy ND array over there. But what is exactly the type? If I say that this is a number, this is a numeric type, right? But what exactly it is? It is an integer type. Similarly, if I say that what is the data type of this array? So this is a type of an ND array, but what is a data type? So data type is integer of 64 bits. Okay. So integer of 64 bits. Now let's say, can we change the data type? Yes. So we can write it as array, and right, and here if we say the d type to be np dot boolean. So when you print this ARR, you will be getting all the results, that is 0, 1, 2, 3. Now we know that the 0 always states to a false statement. So you can see the 0 to be the false and the rest to be the true. Okay, fine. Similarly, you can even change the data type. Just like, let's say this is of a boolean. So you say ARR dot s type. S type to change the data type to anything, right? np dot float. Okay. So just write up the float and you will be seeing up the data, or you will be seeing up the values. So 0, 1, 2, 3 is being converted in this false, true, true, true. And if we convert this false, true, true, true in the float, then false would be 0 and true always is 1. So that is your outcomes. Got it? So if I say ARR, that is one, two, three, four, five, and we say the data type to be np dot complex, right? And now we know, right? With the data, you can see that this is a one dimension array, right? If you see up the things, this is a one dimension array. But I want it to be a three dimension, right? I want it to be a three dimension, or I want it to be a two dimension or 10 dimension like that. So what I can do is I can define my NDMIN, not NDIM now, right? So I'm not going to define the number of dimensions. I'm going to define the minimum number of dimensions to be 3 or 2, whatever you want. So there is difference between the ND mean and the the ND mean and the NDIM, right? So you are making an array with one dimension, and you are also changing the data type to complex, and you are saying that the number of dimensions what you have written 1 should be 3, and you run this, right? Now you see your ARR, you can see that this is a 3-dimension array. You can see 1, 2, 3, and you can see 1, 2, 3. Okay, so this is now a 3-dimension array where you are having all the elements as a complex number. Okay, alright. So like this, you can even change the data types. So if you want to find the data type dot the name of the data type, so you can get it as complex 128 bytes. So now if we want to see the element size, guys, if you remember of the things, that if we say the get size of an integer, the get size of any integer leads to 28 bytes. The get size of any float gives you 32, and complex gives you 32, right? If we just see of get size of complex, any complex, you'll be getting 32. Similarly, for the float, it's 24. 24, I think it's 24. Let's see. Yes, for the float, it's 24. Even if you enlarge the things, still you'll be getting the same output, 24, right? So the size of these things remains same. Similarly, if we have any integer or any kind of float or data type, if we just see a complex over there, so what is the size of the complex numbers? What is the element size? What is the individual item size? If we find the whole size of this array, find the whole size of this array is 128 bytes, right? 128 bytes. So that is being presented to you, right? That is complex of 128, right? But what are the element size? So for element size, ARR dot item size, if you write, you will be getting every individual element item size. That is 16. And now how it is 16? It is like whatever the size is there, right? Let's say 128 is there. So you divide it by 8, and the answer you will be getting is your item size. Okay. So for like this, you'll be getting up the item sizes. Alright. Cool. So you have seen the item size, how to see the item size from your data, how to find the number of dimensions, how to see the minimum number of dimensions, how to change the data types using the as type. Alright. Moving up next. Now, let's say that if you have X as an array, and this is 4, 5, and 6. So this is your array, basically 1, 2, and 3, and 4, 5, and 6. Now, the number of dimensions we know is to be 2, and if we just print up the X, you'll be getting up like this, right? So what is the shape? So we also know the shape is 2 cross 3. But let's say if I want this in 3 cross 2, right? That is, I want to change the shape. I want this in 3 cross 2. In that case, I can write it as X dot reshape. right? Reshape of 3 by 2. So 3 rows and 2 columns is the my expectancy, right? So I'll be writing it as x dot reshape 3 cross 2 or 3 by 2, and we'll run this. So x will be just printed up in some 3 cross 2, and it will be 1, 2, 3, 4, 5, and 6. Similar to that. Okay? Think you might have got the 6, right? So, okay, moving up, right? 5. So, if you have any dimension array and you want to make it in one dimension, you have one method that is very interesting. That is x dot ravel. Write the array name and then write the ravel. This will what this will do is this will just reshape your array in one dimension. Even if it is an 100 dimension, 50 dimension, 20 dimension array, it will reshape up the things in one dimension. If you can see, this is a 2 cross 3 array or 3 cross 2 array, even if it is being printed in one dimension. Fine. Now we just take some y and np dot array. They just make it something different from this. 12, 13, 14. 15, 16, 17. That's nice. So what is y this? What is x this? Right? Cool. Now if you want to add up this x plus y, you can just even add up the things and you can get it as 11 plus 12 plus 1, 13, 13 plus 2, 15, 14 plus 6, 17, and so on, right? But what if I want to just join these things? I don't want to add up. So I can write there np dot concatenate this x and y. So spelling error. So you could see the concatenation, that is an array, and you're seeing 1, 2, 3, 4, 5, 6 first, and then you're having 12, 13, 14, and 15, 16, 17. And by default, every time, all the operations you're getting in the numpy or let it be in the scip, anything there, right? So every time you'll be getting up the things in the column wise, okay? The vertical. Cool. So let's say now if I say that np dot concatenate, and it all only takes one parameter, so that we have to make it one double inside there, and then we can write it x and y. So let's say this is x and y, and now we say that the axis we want is 1. So you can see the concatenation. The axis 1 means row wise concatenation. So row wise concatenation means that if you see your x and y, this is 1, 2, 3, and this is 12, 13, 14. So in the row wise, the first row is 1, 2, 3 and 12, 13, 14. The second row is 4, 5, 6, and so that's the 15, 16, and 17. Okay, or like that. Next. So if in place of this 1, if we use it to like run it by the x is 0, so you'll get the exact output what you get on the starting without using any axis, that is 1, 2, 3, 4, 5, 6, and the same as to the previous one. So that I was saying that every time the very beginning thing is always by the vertical things, right? Always by the column wise. So the column wise is the default operation in this numpy. Okay. For every operations you'll be going on. So for removing this axis, there we have some another function called as stack. So if you say v stack, that is a vertical stacking. So vertical stacking of x and y will give you a vertical stack. But if we want a horizontal stack, we'll be using x stack, and we could get it as x and y. So the same output without writing the x's. Okay, fine. Now, So if we see up the indexing, so x is having your 1, 2 and 3. So if I say x of 2 to 3, okay, index is out of bound, 1 to 2. So you can see x of 1 to 2 is 6. Now what is x this? What is x of 1, right? What is x of 1? So x of 1 is 4, 5 and 6. So what is x of 1 of 2? So x of 1 and of this 1, what is the 2? That is 0, 1 and 2, that is 6. So you're getting up this right there, right? So let's say that there is an array and we are going to find 0, 1 and 2. Okay, 2 is fine. So 0, 1 and 1. So that is 4. Now how it is possible? For the 0 and 1, you are getting 1. How? Why are you getting 4 out? So what is the ARR of 0? First of all, very beginning thing is to understand what is the ARR of 0. That is 0, that is 1, 2, 3, 4 and 5, 6. Now what is the ARR of 0 of 1? So inside this 0, what is the 1? That is 3 and 4. Now inside this 3 and 4, what is the 1? That is 4. Okay, so I think you might get it, right? Basic things, the basic ranges and all, right? The stepping things and all. Okay, so like that you can index over a particular array. Okay, cool. All right. Next we see up the mathematical skills, right? The mathematics we are talking about. So we'll be seeing up that also, right? Okay, let's say that if we have a number that is D1 and D2 and we have it as 32 or 0 and 0.5. So we have the number D1 and D2 as 0 and 0.5. And what is the question is? What's the question? So the question is that we want to print some 200 numbers between 0 to 0.5 in an equal distance. And that is possible, right? So printing the numbers from 0 to 0.5 and that to 200 numbers with the equal distance. If the equal distance means that if I say a question of an arithmetic progression, so what you find the D, that is a common difference, that remains same for the whole progression, right? For the whole series, for the whole sequence. Similarly, if I say that I want the numbers, 200 numbers, there should be that common difference. There should be that linearity of the intervals of the steppings, you can say on, right? Okay. So we want like this to be done there, right? So what you can use is there is a function, right? There is a function linspace working out there for for spacing the between the numbers, for creating a space between the numbers, a linear space between the numbers, and calculate and taking the you can say printing out the numbers as much as you want with the linearity. Okay, fine. Okay, now, so to find the length spaces, like let's say if we are saying it to be a let's say q, and we are saying np dot length space, so space. So np dot length space of, let's say we have given 1 to 2, and let's just run this. So what is q? You can find it there, that there is some numbers, some list of numbers or array of numbers. How many numbers are there? Exactly 50 numbers. Okay, so we just find the size of this q, we'll find it to be 50. Okay, so how many numbers are there? 50 numbers. So what is there? What you can see is there, by default you will be having 50 values. Okay, when you write up a linspace, by default you will be having 50 values. So you can even specify up your things. So let's say we want now a length space of numbers starting from D1 going up to D2, right? And we want to find our red step, right? Red step means returning step, right? So we can assign, if you remember of the things, that is T of n is equals to a plus n minus 1 multiplied by d. This is actually the format, if you guys remember of the progression problems, right? So this is the format of how you calculate the things. So let's say here our Tn is 200, right? That is, we want some 200 numbers, and our first number is 2, and our second number, that is the n, is, or the last number is 4, right? This is the case we are having, and we need to find out the d. If you understand the things, right? We need to find up the d. Okay. So how to find it there, right? Let's say we are just writing a length space of a to n, and the numbers you want is 200, right? And you want that you should return the red step to be true. That means that you want to print the stepping value or the interval value you are getting in your answer, or the common difference, you can say your red step to be the common difference. So this is something about the length space you are getting, okay, and it'll run this. So what you can see is there all the 200 numbers starting from 2 and going till 4, and after 4 we have got some numbers, that this is the common difference, or you can say the red step value, okay. So this is a common difference or the red step you are getting up in your what to say this as an array, right? So you're getting this as an array, okay. All right, now so what you can see that there are some 200 numbers with an equal linearity between them, right? And you have got all the things regarding to that. All right, moving up. Similarly, if you want to find the log of some numbers, so we have it as log 10, and that too of 10. So log 10 of 10, log 10 of to the base 10, what is the value? That is 1.0. But when you want to find a log space of some numbers starting from like 1 to 2, and you want some 10 numbers only, and you just run this. So the log space of first 10 numbers, that is from 1 to 2. So from 1 to 2 the log space is this, right? So there are a lot of functions working with this all mathematics sectors, okay. All right. Okay. Now, let's just say that if you have some numbers 2, 4, 6, 8, 10, and I say you, right, that find the LCM of this. So that is very easy task, right? So that is an LCM of this one. That's it. So invalid number of arguments is given. Okay. Cool. 1 minute. We'll reduce this, and you can see the LCM to be 120, right? So it is invalid because you can write at most 2 things at a time, right? Like np dot LCM of 3 or 15, that is 15 exactly. But if you write more than 3, you will have to reduce it to make it one thing so that the LCM could be taken up easily, right? So similarly, if you have an array, what is an ARR? This is an array. I want to find the LCM of 1, 2, 3, 4, 5, 6. So what will be the LCM? That is np dot the LCM dot reduce. Always when you're finding the LCM of an array, always reduce the things. So reduce this array. Everything The LCM is 1, 2, and what is this? Hmm? 1 minute. Something wrong is there. Yep. So LCM is 60. Okay. What is their difference? I didn't know that. One, two, three, four, five, six. And this is why it is not being reduced. Cool. So what you do is, if you are getting some bad answers, the only like the best way is first convert it in one linear and then find the LCM. It will work. Okay. Fine. So this method ARR.T is particularly used for transpose. If you remember up the things. So this is X and this is X dot T, that is transpose. NP dot transpose of this X. So this is the transpose, right? Okay, let it God have. This is the transpose. Even you can find up this matrix. So how to make a matrix? Let's just say an info of matrix. So a lot of thing is there how to make matrix with all the methods you are getting up here. So matrix is particularly an array-like object or a form of a string of data. So the parameters it takes is the array like a string, the data type, copy, and you can make it with this all. So matrix of 1, 2 has the semicolon and then the 3 and 4. And put a matrix of this kind of thing, and you can get a matrix instead of an array. So you can write up the things. You have flatten, you have fill, you have terms, item, minimum, mean, and a lot of methods, right? Here to work with, right? It is from any arg max and all the methods you have got it there, and what is the use of those methods even you have got it there, right? So what is the use of flatten, what is the use of max, what is the use of ptp, what is the use of ravel? So returned a flattened matrix, right, or a 1D array. What is the reshape, what is the use of round, the set size, and all of the things, right? So you can get it with that respect also. Okay. Now, where were we? The matrix, right? So like there, like if we use T or transpose, we can find a transpose, or like we can swap up the x's and all. Okay. Now, let's say if I am saying that I want to find from here only. So if I want a zero matrix, so that is zeros of 10. So a flattened matrix, that is a 10 size of flattened matrix with all the zeros. Similarly, if I say it for ones of the 10, the same thing. And if I say it for an I means an identity matrix of 10. So when I say an identity matrix of 10, I mean to say that there must be an identity matrix or one in the diagonal way, in the right, from left to right. So you're getting it from the left to right, right? You can even change the data type to the boolean or the kind of, let's say the type to be np dot integer 16. And you can see integer 16 data type and the total matrix. If you write the matrix of a 3, so you can get it a 3 matrix. So it is 3 cross 3 exactly. Same we can do with the ones and same we can do with the zeros right there, right? Now, if you guys remember the random thing, that from this random we can import this random and can work with there. So let's say, okay, so np dot rand. Fine. So from this random, if you can see the function of this rand and all, right? So if we write np dot info and if I write np dot random, so you can find all of the things a random can do, random number generation. So what it does exactly. So you can go for bit generator, that is you can generate up the things like this. You can even go with all of the things, right? Compatibility, that is random. So what is rand? Uniformly distributed values. What is random? Normally distributed values. What is rand f? Uniformly distributed floating point numbers. Similarly, you can get up all those things, right? Random integers, random sample, the seed, the legacy random number generator. Unvariate distributions come as beta binomial, size square, and all of the things, right? The logistic and up. There are a lot of things, right? Multivariate distributions, standard distributions, internal functions, and a lot more are things to see with this random. Okay, so where we have choice. So they just give you an idea of how this choice works, right? So random sample from 1D array. Let us see, guys, how it works. If I say np dot random, and if I say dot random of 10, what you can see, some 10 digit numbers, randomly 10 digit numbers. Okay, what do you say that np dot info of np dot permutation? So this permutation, right? This permutation is the task is to randomly permutate a sequence or return a permutated range. So, for example, if you write np dot random permutation of 10, so you get something permutation numbers 174 as it all. These are nothing but the random things, right? So, permutated numbers between the 10 possible numbers, you know better, right? What are the permutations and combinations as per respect to the things. Now here's a shuffle, right? It randomly permute a sequence in one place. So let's say if we write it as np dot random dot shuffle of this file. Okay, sorry. I'll just take an example from here. So you can take any array and then you can reshuffle it. So we can write it as np dot random dot shuffle this x. Then you can print this x 1, 2, 3, 4, 5, 6. That is fine. Now if you say any array, let's say just to copy up this all, I paste it there. Right? So what I'm doing is here np dot arrange of 9. That is, what is arrange? Okay, let me first take you what is arrange. So when I write np dot arrange of some, sorry, not range, this is arrange. Arrange of this is arrange of 10. So this takes the number from 0 to 9. Similarly, like how range works. So if we are writing that a range of 9 and then reshaping this to 3 cross 3, what does this all means? So if you are taking a range of 9 numbers, that is 1 to 8, 0 to 8, and then you are reshaping it to 3 cross 3, this means that this will be in the 3 cross 3 matrix, from 0 to 8 matrix. Okay. Now, similarly, if we just print it there, that is shuffling this ARR and printing this, we can see the shuffle, that is the things has been just shuffled up, right? That is the only use of this thing. Now, if I say that, if I write the random dot rand of some 20 numbers, so you can find some 20 numbers over there, right? But if I want all the random numbers of my choice, right? And I should give how much that number is going to print for the number of times. I should define my things over there, right? So how can I write those things? So let's say this is a random dot this choice, and here let's say I want to distribute 1 to 3, and the percentage, or you can say the probability I'm going to give is 0.3, 0.4 and 0.3, or let's say 0.5, 0.2, and I'm saying the size is to be well as 100. Okay, we'll run this. So what you can see is a 1D array, right, with only the numbers as 1, 2 and 3, and the size, that is the number of elements there, are 100. Okay, and you can see up that 0.3%, or you can say as 30% of the values are 1, 50% of the values are 2, and 20% of the value are 3. Okay, so let's just say it as a R, and if you just print this R, you can get, okay, sorry, this is R, and if I say where in R, where this numbers are equals to 0.3, so okay, sorry, it is 3. So there are so many places, right? So we can just find out the length, that how many 0.3 has been there. So length of okay, 1 minute, sorry. So the occurrence is there 1 itself. So all these places 4 to this all, like if we just copy it there, and we can find out the length of this all. So 26 places are there. Out of 100, 26 are 3. Okay. Now, how many are 2? Got again a lot of things. How many are 2? 50 are 2. That is exactly, now it's being 86. So 100 minus this 86 will be obviously the 1. That is 14 ones will be there. Right, as per the calculation. But let's just see up the things. Oh, sorry, 86. Oh, sorry, this is 76. Sorry. So this is 76. So 24 ones are there. So you can calculate, like you can see of the things. So if we say that 30% and 50% and 20%. So 30% is your 2, okay, and then the 20% is your 1, and the 30% I think is your 2, right? And like this, right? What I didn't see it. Yeah, so 30% is 1, 20% is 3, and 50% is 2. That's it, right? Okay, that is how a random works. Now, let's say, now this, what you see your R is something in an unordered way. If you want to sort this up, you can write it sort, and then you can write R. So you will see a sorted now, that is sorted an array of a sorted array starting from 1, 2, and then followed by the 3 out there, right? So this is how we work up with all this NumPy arrays and all about this calculation parts, right? So what is your work for now is to get it started, right? That is, search for the info, search for this all, like what is this np.nif. So it will convert a string or a number to a floating point number if possible, right? So np.inf to 23, if I say for that. Float is not callable. 0.3, right? So if possible, then only it is going to convert other things, right? Okay. So what is this about the np.nan? So this converts a string again to this. This is a basic definition, but the value is that, right? When you say, when you make a list, or when you are making an array, so what you can see when you run this, that is nan. So length of s 5. But what is the fifth thing? A nan. That is not a number. That is not a number over there, right? That is nan. We'll study it in much detail in the panda section. Okay. So that is how we deal up with the numpy, right? So this is for your practice. Now, how much you practice up with the numpy, because you can do a lot of things with respect to the numpy, right? So tomorrow we'll be starting up with the simpy, right? There will be doing some mathematical things, right? Let this give an introduction. So tomorrow we'll be just importing with this as simpy, as sp, right? Um, let us say from simply I'm going to import everything. So there we can just work up with, let's say there we are writing a, just let's say I'm writing a theta. Mm, okay, just theta, right? And so see, you can take it as sine of this theta squared plus cos of this. If you remember the equations and all. So this is sine square theta plus cos square theta. You take x and y to be the symbols. This is what we are going to discuss tomorrow. All right. So like if we take an expression of x square plus x plus 1. So this is an expression x square plus x plus 1. So if we find the integral of this expression, it would be x cubed, sorry, the integral of this, right? Similarly, if we find the derivative of this, so the derivative of ex would be, there is some, yeah. So the derivative would be dy dx of this, right? So with respect to x, or like even if you write with respect to x or with respect to x, so these are the things, right? Then to find integrate, so to integrate this ex with respect to x, you'll be getting up this x cubed by 3 plus x squared plus by 2 plus x. Similarly, if we go on differentiating with this ex with respect to x, you'll be getting 2x plus 1. So some basic mathematics is important also in the field of data science, right? Because it's still all about the data. So we'll be doing it tomorrow, all right?